All right, welcome. In this screencast, we consider how many positive factors a whole number happens to have. In this screencast, let's consider the number 72. The number 72, if you were to break it down into primes, is 2 cubed times 3 squared. Let's consider the number of factors of 72. How many positive whole numbers divide 72 evenly? Let's look first at the 2 cubed. How many divisors are there of 2 cubed? Well, 2 cubed is 8. So the numbers that divide 2 cubed are 2 to the 0, 2 to the 1, 2 to the 2, and 2 to the 3. Those are the only numbers that divide 2 cubed because 2 cubed is a prime number cubed. So we either have no factors of that prime or 1 or 2 or 3 factors of that prime. There are 4 divisors of 2 cubed. Well, now let's look at the factors of 3 squared, the divisors of 3 squared. Well, how many are there? Well, again, 3 is prime, so we have 1 or 3 or 9. Those are the only numbers that divide 9. There are 3 of them. So the question becomes, how many divisors are there of 2 cubed times 3 squared? How many factors are there of 72? Well, we can take any one of these and multiply it by any one of these. We could do 2 to the 0 times 3 to the 0, or 2 to the 0 times 3 to the 1, or 2 to the 0 times 3 to the 2. Or we could do 2 to the 1 times 3 to the 0, or 2 to the 1 times 3 to the 1, and 2 to the 1 times 3 to the 2. So, I mean, we could nail them all here. We could write them all out. We could just take the time to write them all out until we had 72. 4 times 3. There are 12 divisors of 72. So here's the way I want to say it. If P and Q are primes and M and N are whole numbers, then P to the M times Q to the N has M plus 1 times N plus 1 divisors. And this generalizes to multiple products of primes. Why? Why does that work? Well, for exactly this reason. When we have a prime number to a power, that power is the highest divisor, and then we just take all the powers below it all the way down to 0. So there aren't 3, there are 4. That power is the highest power, and then we take every power that's less than that. So there aren't 2 divisors of 3 to the 2, there are 3 divisors of 3 to the 2. And then we just pair everybody up, all of these with all of those, and 4 times 3 is 12. P to the M, Q to the N has M plus 1 times N plus 1 divisors. How many factors do these numbers have? So consider with me the number 10,000, and then consider with me the number 20 to the 19 power. Think for a moment, hit the pause button, scribble something down. How many factors do these numbers have? I'm about to give it away. Okay, I'm going to give it away. So 10,000, that's 10 to the fourth. That's 2 to the fourth times 5 to the fourth. 10's not prime, but 2 and 5 are. So 2 to the fourth has 5 divisors, and 5 to the fourth has 5 divisors, and 5 times 5 is 25 factors of 10,000. We could write them all out. 1 in 10,000, 2 in 5,000, 5 in 2,000. We could write them all out, but we don't have to. We just count them up. Take a look at 20 to the 19 power. Well, 20 to the 19 power, well, what's 20 as primes? Well, that's 2 to the power of 2 times 5. All of that to the 19 power. And you were pretty good in algebra when you were in school. This is 2 to the 38th power times 5 to the 19th power. So how many factors does this number have? Well, 2 to the 38 has 39 divisors, and 5 to the 19 has 19 plus 1 divisors, and that's 780 divisors. So it is not hard to figure out how many factors a number has if we can break it down into primes, If we can break the whole number into primes, then we can figure out the number of factors. And so that makes primes super valuable. And that's why our next screencast takes a look at how to know if a number is prime.